prepare for an electrician's exam, several key resources and strategies can prove helpful. Recommended literature includes Mike Holt's Exam Prep for the Journeyman Electrician Exam, Electrical Apprentice Exam Prep Journeyman Electrician by Michael Thomas, The Electrician's Exam Study Guide by David Howes, Electrical Blueprint Reading Workbook by Stan Javeliska, and Delmer's Standard Textbook of Electricity by Stephen L. Howman. Essential materials include a National Electrical Code book, a calculator, pencils, erasers, and blueprint reading tools like a ruler, scale, and protractor. Consider enrolling in relevant courses such as Mike Holt's Electrical Exam Prep courses, the International Brotherhood of Electrical Workers Apprenticeship Training Program, National Joint Apprenticeship and Training Committee Training Center courses, and courses offered by local community colleges or technical schools. It is crucial to study consistently by setting aside dedicated time each day. Use multiple resources to reinforce concepts. Solve as many practice questions as possible to simulate the exam experience. Focus on understanding concepts rather than simply memorizing formulas. Thoroughly review the National Electrical Code, as it serves as the primary reference for electrician exams. Develop blueprint reading skills, which are essential for understanding electrical schematics and code requirements. Manage your time effectively during the exam, allocating time wisely for different sections based on their weight. Maintain a calm and confident attitude, taking deep breaths and focusing on answering the questions one at a time. Additional resources can be found at the National Electrical Contractors Association website / the International Brotherhood of Electrical Workers website / and the New Jersey Bureau of Labor Statistics Electrician Exam Information page at. Effective preparation involves a combination of comprehensive study materials, practical tools, structured courses, and strategic study habits. Firstly, it is highly recommended to familiarize yourself with the National Electrical Code. This code serves as the cornerstone of electrical installations and safety standards. Spend time understanding its structure, articles, and specific requirements related to various electrical systems and equipment. Secondly, practice extensively with sample questions and exams. These resources will help you assess your knowledge, identify areas of weakness, and improve your test-taking skills. Look for practice exams that closely resemble the format and content of the actual electrician's exam. Thirdly, consider enrolling in an electrician exam preparation course. These courses typically offer comprehensive reviews of electrical theory, code requirements, and exam strategies. They often provide valuable insights and guidance from experienced instructors. Fourthly, master electrical blueprint reading. Blueprints are essential for understanding electrical systems and interpreting code requirements. Practice reading and interpreting electrical blueprints to improve your comprehension and problem-solving abilities. Fifthly, develop a solid understanding of electrical theory. This includes topics such as Ohm's law, Kirchhoff's laws, series and parallel circuits, alternating current and direct current circuits, and electrical components. Sixthly, familiarize yourself with electrical safety practices. Safety is paramount in the electrical field, and it is essential to understand and adhere to safety regulations and procedures. Learn about lockout-tagout procedures, personal protective equipment, and other safety measures. Seventhly, create a study schedule and stick to it. Consistency is key to success in exam preparation. Set aside dedicated time each day or week to study and review the material. Eighthly, seek out mentorship from experienced electricians. Talking to experienced electricians can provide valuable insights and guidance. Ask them about their experiences with the exam and seek advice on how to prepare effectively. Ninthly, stay updated on the latest code changes. The National Electrical Code is updated every 3 years, so it is important to stay informed about any changes or revisions. Review the latest edition of the code and understand how it affects electrical installations and safety standards. Finally, take care of your physical and mental well-being. Exam preparation can be stressful, so it is important to take care of yourself. Get enough sleep, eat healthy, and exercise regularly. These habits will help you stay focused, motivated, and confident on exam day. The National Electrical Code, often referred to as the NEC, is a comprehensive set of standards and guidelines for safe electrical installations. It's published by the National Fire Protection Association, or NFPA, and updated every 3 years. The NEC covers a wide range of topics, including wiring methods, overcurrent protection, grounding, equipment installation, and special occupancies. It's essential for electricians, electrical inspectors, and anyone involved in electrical work to be familiar with the NEC. Understanding the NEC is crucial for ensuring the safety of people and property. The code provides specific requirements for electrical installations to minimize the risk of electrical shock, fire, and other hazards. Compliance with the NEC is often required by law, and electrical inspections are conducted to verify that installations meet code requirements. The NEC is organized into chapters, articles, and sections, each addressing specific aspects of electrical installations. Chapter 1 covers general requirements such as definitions, wiring methods, and conductor sizing. Chapters 2 through 4 cover specific types of installations, such as dwelling units, commercial buildings, and industrial facilities. Chapters 5 through 8 cover special occupancies and equipment, such as hazardous locations, swimming pools, and emergency systems. It is important to understand the structure of the NEC and how to navigate its various sections to find the information you need. The NEC includes numerous tables and examples to help you understand and apply the code requirements. These tables provide information on conductor ampacity, overcurrent protection sizing, grounding electrode sizing, and other important parameters. The examples illustrate how to apply the code requirements to specific situations. In addition to the NEC, there are other resources that can help you prepare for the electrician's exam. These include study guides, practice exams, and online courses. These resources can provide valuable insights into the exam format and content, as well as help you identify areas of weakness. It is important to use a variety of resources to prepare effectively for the exam. Consider the resources available from the National Electrical Contractors Association and the International Brotherhood of Electrical Workers. Also consider resources from the New Jersey Bureau of Labor Statistics regarding electrician exam information. Let's take a moment to discuss Ohm's law, which is a fundamental principle in electrical engineering. Ohm's law states that the voltage across a conductor is directly proportional to the current flowing through it and the resistance of the conductor. Mathematically, Ohm's law is expressed as volts equals amps times ohms. This simple equation has wide-ranging applications in electrical circuit analysis and design. It can be used to calculate voltage, current, or resistance in a circuit, provided that the other two values are known. For example, if you know the voltage across a resistor and the current flowing through it, you can calculate the resistance using Ohm's law. Similarly, if you know the resistance of a resistor and the current flowing through it, you can calculate the voltage across it. Ohm's law is also used to determine the power dissipated by a resistor. Power is the rate at which energy is transferred, and it is measured in watts. The power dissipated by a resistor is equal to the voltage across the resistor times the current flowing through it. Alternatively, it can be calculated as the current squared times the resistance, or as the voltage squared divided by the resistance. Understanding Ohm's law is essential for analyzing and designing electrical circuits. It allows you to predict how voltage, current, and resistance will interact in a circuit and to calculate the power dissipated by various components. Kirchhoff's laws are another set of fundamental principles in electrical circuit analysis. Kirchhoff's current law, also known as KCL, states that the algebraic sum of currents entering a node or junction in a circuit is equal to 0. In other words, the total current flowing into a node must equal the total current flowing out of the node. This law is based on the principle of conservation of charge, which states that electric charge cannot be created or destroyed. Kirchhoff's voltage law, also known as KVL, states that the algebraic sum of voltages around any closed loop or path in a circuit is equal to 0. In other words, the total voltage drop around a closed loop must equal the total voltage rise around the loop. This law is based on the principle of conservation of energy, which states that energy cannot be created or destroyed. Kirchhoff's laws are used to analyze complex electrical circuits by breaking them down into smaller, more manageable loops and nodes. By applying KCL and KVL to these loops and nodes, you can determine the voltage and current in various parts of the circuit. These laws are essential tools for electrical engineers and technicians. Conductor ampacity is the maximum current that a conductor can carry continuously without exceeding its temperature rating. The ampacity of a conductor depends on its size, material, insulation type, and installation conditions. The National Electrical Code provides tables that specify the ampacity of various conductors under different conditions. It is important to select conductors with adequate ampacity to ensure that they can safely carry the expected current. Overcurrent protection is the use of devices such as circuit breakers and fuses to protect electrical circuits from excessive current. Overcurrent can be caused by short circuits, overloads, or ground faults. Overcurrent protection devices are designed to trip or blow when the current exceeds a predetermined level, interrupting the flow of electricity and preventing damage to equipment and wiring. The National Electrical Code provides specific requirements for overcurrent protection, including the size and type of overcurrent devices to use in various applications. Grounding is the process of connecting electrical equipment and systems to the earth to provide a low impedance path for fault current. Grounding helps to protect people from electrical shock and to prevent damage to equipment in the event of a ground fault. The National Electrical Code provides specific requirements for grounding electrical systems, including the types of grounding electrodes to use and the methods for connecting equipment to the grounding system. Blueprint reading is an essential skill for electricians and other electrical professionals. Blueprints are technical drawings that show the layout and details of electrical systems. Blueprints typically include information on wiring diagrams, conduit runs, equipment locations, and control systems. Being able to read and interpret blueprints is crucial for understanding electrical systems and for installing and maintaining them correctly. Review Article 90 of the NEC. It covers the purpose, scope, enforcement, and rules for application, as well as the organization of the NEC. Article 100 provides definitions of terms used in the NEC. Article 110 covers the requirements for electrical installations. Chapter 2, Wiring and Protection, provides the requirements for the use and identification of grounded and grounding conductors, branch circuits, and feeders. Chapter 3, Wiring Methods and Materials, provides requirements for wiring methods and materials. Chapter 4, Equipment for General Use, provides requirements for the installation of utilization equipment. Chapters 5 through 7 supplement or modify the general rules and cover special occupancies, special equipment, and special conditions. Chapter 8 covers communication systems. Chapter 9 contains tables and examples used throughout the NEC. Annexes are not part of the requirements of the NEC, but are included for informational purposes. Be sure to familiarize yourself with these as well. Successfully navigating the electrician's exam hinges on a multifaceted approach. Solidify your foundation with recommended literature, enhance practical skills with essential tools, and consider structured courses. Supplement theoretical knowledge with hands-on experience. Integrate these resources with effective study habits, and reinforce understanding through sample questions, code books, and blueprints. The blueprint reading is the actual understanding of electrical schematics and also code requirements. Practice questions will help you to be familiar with the exam experience and can give you a better understanding of what to focus on. Remember to review the NEC or National Electrical Code thoroughly, as it is the primary reference for the exam. Do not only memorize formulas but understand the concept to have a deeper understanding of the electrical work. Do not fret during the exam and allocate your time for each section based on the weight of the questions. Stay calm and be confident.